And now for the graphs of tangent and cotangent. By far, the more important of the two is tangent. In fact, it's important enough that I'm even going to add it to my little 3x5 card right here. So tangent is undefined right here at negative pi over 2, and also right here at pi over 2. So it has these two asymptotes represented by the red lines. And then the graph of tangent itself goes like this, and on this side it goes up to infinity, and over here down to negative infinity. Well, why the asymptotes? So tangent of x is equal to sine divided by cosine. That means anytime cosine equals 0, tangent is going to have division by 0 and be undefined. So when does cosine equal 0? So here's the cosine graph. And then right here, it's equal to 0, which is pi over 2. And right here, it's equal to 0, and that's 3 pi over 2. And if you were to continue the graph this direction, then right here, it's equal to 0 again, and then that's at negative pi over 2. So in all of these places, tangent is going to be undefined because of division by 0. So basically right now I'm just going to repeat that graph that I have on the 3x5 card and then tell you some other important things about it. So these dotted lines are the asymptotes. Asymptote is spelled that way. And there's one at negative pi over 2. There's another one at pi over 2. Now because sine of 0 equals 0, tangent of 0 equals 0. So it goes through the origin. And then it's going to grow like this and go up towards the asymptote. It's not going to cross it. It's just going to get closer and closer to it. And the same over here. So for one thing, the period is the length on the x-axis that it takes to draw one cycle. And from half of a pi negative to half of a pi positive, that's a whole pi. So the period is pi. For sine and cosine, it's 2 pi, but for tangent, it's pi. Another important thing is amplitude. So amplitude goes from the middle to the very top of the function. Well, this would be the middle, but the top is going up to infinity. So for amplitude, well, we don't really say it's equal to infinity. So we just say that it's not applicable. Although if you did say infinity, I would not take off any points for that, doing that. All right, then let's do one like this. How about y is equal to negative 2 tangent of 3x. So first of all, the negative will invert it. So instead of this part going up, it's going to go down. And instead of this part going down, it's going to go up. That's what the negative will do. The 2 is going to make the y values twice as big. So let's say that right here, the y value is 1. Well, then the y value would be 2. So it's going to make it grow faster, although with the negative, it would be going down faster. Okay, like with the other ones, I still like to put what's the x information and what's the y information. So there is, first of all, the period. So originally, tangent has a period of pi. Then you need to divide by this number. So it's going to be pi divided by 3. Then the horizontal shift or the phase shift, this has none because it doesn't have plus pi or minus pi or anything like that. So either say none or 0. Then the amplitude, not applicable. And then vertical shift. So that would be if like this said plus 17, then this would be moved up to 17. And then you draw that side and you draw that side. Here, there is none. Okay, since the period is pi over 3, and that has to be split into 2, because half of it goes here and half of it goes here. Like the period is pi, but half of it's here and half of it's here. Then we need to know what's half of this. So if you cut that in half, that's going to be pi over 6. So that means that over here at negative pi over 6, and here at positive pi over 6, it has asymptotes, which you don't have to make red, but you should make them dotted lines. There we go. And then the negative is going to make this side go down and this side go up. And I tried to make it look like this is going up a little bit faster than the original graph. Let me show you on the calculator what I'm talking about. So y equals just tangent of x. And then go from negative pi over 2 to pi over 2. And the y values from negative 10 to 10 should be good enough. And then take a look at the graph. So that's this graph right here, the original tangent of x. And then what if I put 2 tangent of x? So then you'll see in here, the blue one, it's growing a little bit faster, so it's above, it's literally twice as tall as the red one. So that's what I was trying to do in here. It doesn't have to be perfect. Okay, then this one was, let me insert a negative 2 tangent, insert a 3, and now I need to adjust this on the x-axis. Go from negative pi over 6 to positive pi over 6, and the graph should look just like this. And as you can see, it's graphing it just like I did, although they don't put the arrows. And they also don't put the dotted lines for the asymptotes. Let me widen the window. Let's see, how about negative 1 to 1? Widen the window. And you'll see, so tangent would repeat. So you only have to draw one of them for one cycle, but then it would repeat. There would be another one going like this, and another one going like this. So that's what we're seeing, is more than one cycle. But the calculator is not going to put the dotted lines. It's not smart enough to do the asymptotes. But we are. Next up, how about, for example, number 2, y is equal to 2 plus 3 tangent 2x minus pi. Now because of this 2 right here, we need to factor that out. 2 plus 3 tangent, and then I'll put square brackets, factor out 2. So as I mentioned before, that's just like dividing each one of these by 2. To get rid of the 2, you divide by 2, and now it's just an x. And this one will be pi over 2. And of course, you could always check my work. You could distribute and go 2 times x. Yep, that was 2x. 2 times pi over 2, those 2's will cancel, and you would just have minus pi. Now the x information and the y information. So for the x information, the period is equal to, so for tangent, it starts with pi, and then it needs to be divided by this 2. So it's pi divided by 2. Then for shifting it left and right, aka the phase shift, that's going to be pi over 2 to the right. The amplitude that would be infinity or not applicable. And then for the vertical shift, that would be this number right here. So it's adding a 2, so 2 up. Okay, now let's see. So when you start, here's how I'd prefer to do it. So usually I would write x's between these numbers, but with this it's easier to take the original graph. It has asymptotes. The original one has asymptotes at pi over 2 and negative pi over 2. But then because of this, I have to divide that by 2 or cut it in half. So that means that each one of these needs to be cut in half. So this would be pi over 4, and this would be negative pi over 4. Now shift those to the right. So this we'll need to add pi over 2, and this we'll need to add pi over 2. Well, this really means a half minus a quarter. Half of a dollar minus a quarter is a quarter. So it's going to be 1/4 of pi. So 1/4 of pi would be over here. This is a quarter plus a half. And if you have half a dollar plus a quarter, that's 75 cents. 75 cents is also known as 3/4. Of course, you could also go like this. Just leave off the pi for a moment, and this is a quarter plus a half, and then go to math, change that to a fraction, and it's 3/4. And then put the 3/4, but now attach the pi back to it. All right, those are the asymptotes. Now, for the next part, it needs to be shifted up by 2. So the tangent graph would go like this, and it would be going through the origin. Well, that part now needs to be shifted up by 2. So on the y-axis, there's 1, there's 2. So this point right here needs to be shifted up. So right here in the middle, it needs to be shifted up by 2. And then this part will go down, and this part will go up. Okay, then on to example number 3. For example number 3, I'm going to draw the picture, and then you come up with the function. So it's got these two asymptotes. This one is at 2 pi. This one is at pi. There we go. There's the picture. Then what function would do that? So going from 1 pi to 2 pi, that's a length of pi. So that means that the period is equal to pi. When it's sine and cosine, the formula is 2 pi divided by b for period. But for tangent, it's pi divided by b. And pi divided by 1 would equal pi, so that means that b is equal to 1. Then this thing got shifted over because it's usually drawn over here, but now it's being drawn over here. So what's in the middle of 1 pi and 2 pi? Well, that would be 1.5 pi's. And you could change this mixed number to an improper fraction, 3/2. So that means that the phase shift is equal to, so this right here is 3/2 pi, is 3/2, whoops, that was not good, 3/2 pi, and it was to the right. And then amplitude doesn't apply, but this has a vertical shift that it got shifted up by 3. So the function is going to be y equals, so it is the tangent function, and then this is going to have to be what got factored out, sort of like I'm basically doing this right here, trying to figure out what's in front of the x. And according to my math over here, that would be a 1 times, shifting to the right actually means x minus 3 pi over 2. And then vertical shift plus a 3. And now I'm excited to see, did I get it right? So graph y equals, slow down there, cowboy, tangent, and then I guess I don't really have to put 1 because 1 times it doesn't change it, x minus 3 pi divided by 2, and then at the end plus a 3. Now make the window look like this. So go from pi to 2 pi, and then that part could stay the same. So it's looking the same. I mean, they draw theirs a little bit flatter. Also, keep in mind that this screen is not a square. So that means every time you're looking at a graph on this screen, it's been stretched this way. So if you take mine and you stretch it so that it's a rectangle, it'll look more exaggerated like that. Then I just need to check this point. Trace and put 3 pi divided by 2, and it says y equals 3 right there. So that part is right. Okay, good. Now for the last part of this section, cotangent. So for the cotangent graph, keep in mind that cotangent is equal to 1 over tangent. So if you look at the tangent graph, it would look like this. It would equal 0 right here. It would look like this. It would equal 0 right here. And this would be when x equals 0. This one would be when x equals pi. So anytime tangent is equal to 0, this is going to say 1 divided by 0, and cotangent will be undefined. So that means at 0 and at pi, tangent will equal 0. That means cotangent is undefined. That means cotangent has asymptotes. That is a good job for the red pen. Make a nice dotted asymptote right here. And another one right here. Then right here in the middle, that would be pi over 2. And because it's 1 over, then instead of going this direction, it's going to flip it. So it goes this direction instead. Now to do that on the calculator, you basically have to type this in, because my calculator does not have the cotangent function, so I have to go y equals 1 divided by tangent. And then set up the window like this. So go from 0 to pi, and that part can stay the same from -10 to 10. And then it draws it. Right there should be pi over 2. So I need to check that part. Trace and put pi divided by 2, enter. And It says that it is undefined. Oh, there it is. Now it says it's 0. Okay, not sure what the calculator is doing, but there's the graph.